In this video, I will be covering problems 1, 2, and 3. In problem number 1, you are starting in factored form and converting the factored form equation into vertex form based on the discussion we've had in class. And then in problem 2 and 3, you're going to take the first two problems on the left side in problem 1 and convert both those into general form. The goal of this activity is to look for a pattern between the x value of the vertex and the b value in general form. So again, one of the things you have to be able to do in this chapter is be able to work between the three forms. So I will be using the same program I was using in the previous videos called Graspable Math. So something already set up. So the first thing you're supposed to do is find the vertex form. And so we do that, we are finding the zeros. So this parabola is going to cross the x-axis at -4 and at -12. So over here we're going to replace, we're going to put in -4 for the first number since it's a 0. And we're going to put in -12 for the second number since those values make 0. So we talked about when you take those two zeros, add them together, and then divide by 2. That's going to tell us the x value of the vertex. To get the y value of the vertex, we take that answer and we stick it in to our equation, and we solve for y. One thing I tried to emphasize last week is that when you get the x value of the vertex, that these two numbers here are basically telling me the real numbers, or the zeros. So in other words, if I decrease the -8 by 4, that's -12, and if I increase it by 4, that's -4, and that's the two numbers that we get for our zeros. So I was thinking about when you're doing these problems that these two numbers here should represent the distance the vertex is, the x value of the vertex is from our two zeros. All right, so we have the two numbers we need. We need an x value, which is -8, and the y value is -16. So in here I'm going to put -8 in here, and -16. You have a double negative here, so in addition, plus or minus here, so this is our final answer for vertex form. So keep in mind that when looking at problem number 2, you're going to be looking for a pattern between the x value of the vertex, which again is -8, and the b value of the quadratic in general form. So we'll come back to this problem here later in the video. So in problem number 2, or second problem number 1, our 0 here is 1, and our 0 here is also, is 7. 7 minus 7 is 0, and here the value is 1. 1 minus 1 is 0. So I'm replacing the first one with a 7, and the second one with a 1. Just notice that I've typed in x or y here instead of x. Let me back up and fix this. So continue, this should have been x instead of y. So again, this is 7's first number. 1 again was the second number. So adding those and dividing by 2 tells me the x value of our vertex will be 4. So you put the x value back into the equation, which is 4, and then we simplify that. So again, the -3 and the +3 is telling me the distance that the real number or zeros are from our vertex of 4. So final answer for the y value is 9, -9. So in vertex form, we're placing the h value here with a +4. That was our x answer. And we're placing the k value with our -9. We have the addition subtraction piece, making just simple subtraction. So hopefully you found the second answer to be the quantity of x minus 4 squared minus 9. Again, we'll come back and take a look at the quadratic in general form in problem number 3. Okay, this problem here, actually the last two problems, all we're going to do is convert it into vertex form. So the two zeros are going to be 2 and 4, since 2 minus 2 is 0 and 4 minus 4 is 0. So the x value of our vertex is 3. So we need to find the y value of the vertex. So I'll stick the x value in here, and we'll simplify these. So the y value is -2 of our vertex. So the final answer is we need to use our a value, which is 2, our x value is 3, and our y value is -2. So here's 2. This one's 3. And this one's -2. The only probably thing I'd do is to make the addition subtraction become just simply a subtraction. Addition of a negative becomes just simply a subtraction problem. So this is the final answer for the third one. And then for the last one, this is -2 makes this a 0, and -8 makes this a 0. So our x value of vertex is -5. We'll stick this back into the equation to find the y value of the vertex. So the y value is 27. Our a value is -3, so we're going to put -3, -5, and +27. So probably the only thing that needs to be simplified here was we have a double negative here. So final answer, hopefully you got, was -3 times the quantity of x plus 5 squared plus 27. If you haven't finished problem 2 and 3, go ahead and complete those problems by turning the factor form into general form, and then turn the video back on to continue. All right, so in the problem 2, we're using basically a generic rectangle to multiply these. So these are the 4 answers you should have in your generic rectangle, and we combine like terms. This is our final answer for general form. So the b value is 16, and the x value of the vertex is -8. So like you'd be thinking about, and you can maybe jot down on your handout what you think are some a pattern between these two things. In other words, if I give you the b value, what would I do to the b value to get to the x value of the vertex? Or if I'm talking about the x value of the vertex, what would I do to that number to go back to the b value? So try to come up with some patterns. This is the first example. Hopefully, as you see this, do a second and a third and so on, you will be able to see the pattern and be able to apply it. In problem 3, if you've not done that one, turn it in general form, we'll go ahead and do that. So here we have, again, the x value of the vertex is 4. And if I simplify my x values here, I get -8. So my b value here is -8, and my h value is positive, or x value of the vertex is +4. And again, what's the relationship between these two answers? So is there the pattern you came up with here, does that pattern still work here? If it doesn't, then be thinking about a different pattern that would work in both cases. But again, the goal here is if I give you the x value of the vertex, how do you get the b value, or vice versa. If I give you the b value, which is actually the one we're going to be emphasizing in this lesson and in the next, how do I get to that x value of the vertex? So the goal here is that sometimes it's just the general form is not factorable, and so how do I turn this thing into vertex form if I can't factor it? Take the average of the two real number solutions, or zeros, and so the goal of this activity in the next is to establish a rule that will allow me to look at any general equation and find the x value of the vertex right away, and then I'm able to use that answer to then plug it back into the equation to find the y value of the vertex. Problem 4 asks you to discuss your pattern with a classmate, and then problem 5 is asking you to look at 3 additional problems, and can you come up with a pattern that's going to work these 3 as well. Please use Desmos to check your answers, make sure you're on the right path. On Tuesday, we'll come back and look at this idea and we will change the a value from a 1 to some other number besides 1 to see if we need to adjust that rule. If you have any questions, come back with those on Tuesday.